Continue with our chapter AP and GP, and here we have a question on AP. It says that the eighth term of an AP is given, and we have to prove that A38 is equal to 3 times A18, where A38 is the 38th term of the AP and A18 is the 18th term of the AP. Here A8 equal to 0, this implies that A plus 7 times D will be equal to 0. That means 7 times D equal to minus A, that means D equal to minus A by 7. Now we will use this value of G equal to minus A by 7 in RHS and LHS both and to get a constant value. So here A38 is equal to A plus 37 times D, replacing D by minus A by 7, we have A minus 37 A by 7. Taking LCM, we have 7A minus 37 A by 7 is minus 30 by 7 times A. In the right hand side, we have 3 times A18. A18 can be replaced by A plus 17 times D, and here replacing D by minus A by 7. Here we have A minus 17A by 7. Taking LCM, we have minus 17A plus 7 is minus 10A by 7 times 3. That is minus 10 times 3 is minus 30 by 7. It is same as the number we got in the LHS. Hence, LHS equal to RHS equal to minus 30 by 7 times A. Proof. Come to the next question. It says that how many two-digit numbers are there which are divisible by 3? Divisible by 3 means it should be a multiple of 3. If we take the multiples of 3 and the smallest two-digit number is a multiple of 3 is 12 after 9. So here 12, then we have 15, then we have 18, then we have 21 like this. The highest two-digit number will be 99, which is also divisible by 3. Now this 12, 15, 18, dot 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 99 forms an AP where this 12 is the first term and common difference is 15 minus 12, that is 3. Hence A equal to 12 and G equal to 3. Now let us suppose that 99 is the nth term of this AP, and that will imply that A plus n minus 1 D is equal to 99. Replacing A by 12, D by 3, we have n minus 1 times 3 equal to 99 minus 12. We have 87. Now 87 divided by 3. We have n minus 1 29. Then n is equal to 29 plus 1. That is n equal to 30. That means there are 30 such numbers which are of 2 digits and are divisible by 3. To the next question, it says that we have a AP whose terms are n minus 2, 4n minus 1, 5n plus 2. Where this is the first term, this is the second term, this is the third term. Only 3 terms are given. Here we find the common difference D equal to A2 minus A1 or A3 minus A2. We have A2 minus A1 is equal to 4n minus 1 minus n minus 2, and A3 minus A2 is 5n plus 2 minus 4n minus 1. Here we have 4n minus 1 minus n minus minus plus 2. Same thing here we have minus 4n minus minus plus 1. Now this is plus 2 minus 1 is 1. Here we have 2 plus 1 is 3. 4n minus n 3n. 5n minus 4n n. Now 3n minus n will be equal to 3 minus 1. 2n is equal to 2, or n is equal to 2 by 2. Hence n equal to 1 here. Okay. Come to the next question. Here we have 3 numbers in AP such that its sum is equal to 3. And we have to find what are those numbers. We can assume let the numbers in AP be A, then D less than A minus D, then D more than A plus D. D is the common difference. The 3 terms will be A minus D, comma A plus D of the AP. Now sum is equal to 3. Sum means adding all these terms, that is A minus D plus A plus D. Minus D plus D will be 0. Then we have 3A is equal to 3. A is equal to 3 by 3, that is 1. Also given that the product of these 3 numbers is equal to minus 35. Here we have A minus D, the first term, multiplied by A plus D. Here we have A minus D multiplied by A plus D, that will be equal to A square minus D square. So A multiplied by A square minus D square will be equal to minus 35. Replacing the value of A, we have 1 time 1 square minus D square equal to minus 35, or 1 minus D square equal to minus 35. Now D square will be equal to 1 plus 35, that is D square equal to 36, or D square equal to plus or minus 6 the whole square. We have 2 values of D, it can be plus 6 or minus 6. Suppose at first we take D is equal to plus 6, we have A minus D, then A comma A plus D. A is what? Here will be 1 minus 6 and here will be 1 plus 6. We have minus 5 comma 1 comma 7. When we take D equal to minus 6, we will get 7 comma 1 comma minus 5. So this is the given AP. Let's move to the another part of this chapter where we are required to find the sum of the first n terms of an AP. And here you have the formula, and the sum of the first n terms denoted by Sn will be equal to n by 2 multiplied by the sum of the first term and the last term, where A is the first term and L is the last term. We can also substitute L by An, where n is the nth term of the AP, up to which we are finding Sn. So n by 2 times A plus An. Come to this question. We are required to find the sum of this AP 2, 7, 12 up to 10 terms. Here the first term is 2, common difference is minus 5, and we will find the 10th term, that is A plus 9D. This 2 plus 9 times 5, that is 47. Therefore, S10, that is sum of this AP up to 10 terms, would be 10 by 2 multiplied by 2 plus 47, the sum of the first term and the last term. So 10 by 2 is 5 times 49, we have 245. Likewise, in this question, we have the AP 1 by 15, comma 1 by 12, comma 1 by 10, up to 11 terms. Here the first term is 1 by 15, we will find the common difference, that is the A2 minus A1. That will be 1 by 12 minus 1 by 15, taking LCM 60, we have 5 minus 4, 1 by 60. So common difference is positive 1 by 60. Here we will find A11 because here the last term will be 11th term. So A11 will be A plus 10 times D. 1 by 15 plus 10 times D is 1 by 60. It will be 1 by 6. Again taking LCM, we get 30. 2 plus 5 we get in the numerator, that is 7 by 30. Now, first term, last term, and the value of n is 11. Now, Sn will be equal to n by 2 times the sum of the first term and the last term, it is nth term. S11 equal to 11 by 2 multiplied by 1 by 15 plus 7 by 30. Again taking LCM, we have in the numerator 2 plus 7, that is 9 by 30. Or we can say 11 9 is 99 by 230 is 60, cancelling by 3. 333 is 320 is we have 3 by 20. This can also be written as 113 by 20. Question, it says that we have a given AP 27, 24, 21 dot dot dot. Let's just go on. It is an infinite AP. Now we will have to find that how many terms we should take such that their sum should be equal to 0. How many terms we should take such that its sum should be equal to 0. Whenever we are getting any sum equal to 0, that means we are adding a number to its additive inverse. That means for 27 we should have minus 27, for 24 we should have minus 24, for 21 we should have minus 21. Likewise, we have to count how many such numbers we have to take such that the sum of the n terms of this AP should be equal to 0. So we are assuming let the sum of n terms of this AP is such that we get equal to 0, then Sn should be equal to 0. Sn is equal to n by 2 times the sum of the first term and the nth term, and nth term can be replaced by a plus n minus 1d, where the first term is 27. N by 2 times 27 plus 27 plus n minus 1 times d. D is minus 3. D is minus 3. A2 minus A1. Now, D equal to minus 3, we have minus 3 times n equal to minus 3n, minus 3 times minus 1 is plus 3, and here we have 27 plus 27 is 54. N by 2 equal to 54 minus 3n plus 3, 54 plus 3 is 57, and these two gets multiplied by 0, we get 0. Then we have n times 57 minus 3n equal to 0, or 57n minus 3n square equal to 0. Substituting this minus 3n square to the right hand side, we have 3n square equal to 57n. We can cancel one n, and we have n is equal to 57 by 3. N equal to 57 by 3 means n equal to 90. That means we have to take 19 terms of this AP. First 19 terms of this AP whose sum will be equal to 0.